So essentially, I'm going to go over through some of the benefits and the benefits to the environmental and forest sector, ranging from the more accurate inventory metrics, increased confidence in the quality of data used for strategic planning, operation, and decision making. I'm presenting this presentation on behalf of Ian Moss, who is my colleague in Tesera. Unfortunately, he couldn't be here today. He's in France right now giving a presentation similar to this on some of his PhD work on sand structure. Ian is the forest inventory and growth and yield specialist at Tesera, and I work with him as part of the team. I've provided the contact information for Ian and myself at the back of the slide, should you want to follow up with any more detailed questions. So just a brief agenda, just briefly go through an overview of Tesera, some of our background with LiDAR, why inventories are important, state of inventories in state of existing resource inventories, some challenges that we faced, some opportunities and some of our expected results, some future opportunities as well, and benefits, some key benefits, and we'll get into some questions. So Tesera has been incorporated since 1997. Our head office as Keith was saying, was in Brockton, Alberta. We have an interdisciplinary team of professionals throughout Alberta and BC, and we're committed to development of innovative technologies and solutions that address land use and land use management. We have a collaborative business model where we work with high-performing teams and build those and for clients. Our teams are not just restricted to Tesera staff. We use external professionals as well to develop teams and to allow each team member to specialize in what they do best. So our our primary services, just quickly, analysis service, stakeholder engagement, IT solutions, and system development. So our background with the LiDAR project. So in 2008 and 2009, we underwent this project on the Spray Lakes Sawmill FMA. It's just outside of Calgary. And the study area is about 26,000 hectares that we use. And I don't know if you can see it well. But there's the purple outline. That's one of the study areas as well. It's here. So they were chosen because they had different ecosites and different ecosites, ecotypes, and that sort of thing. The pilot developed metrics as, for height, volume, basal area, diameter, density by species group, on an 18 by 18 meter cell basis, and that corresponds to the plot sizes we were using. The pilot identified areas requiring areas for improvement, including accuracy of existing ABI species compositions, polygon mapping, and some of the processing techniques we use. Now, in 2010, people were asking us, what's the scale of the cut block accuracy? And we've already seen a number of studies here, but essentially we were getting a pre-harvest volume that was within plus or minus 10%, 95% of the time. And this represents a significant benefit for Spray Lakes sawmills, so that the plant fiber coats, the mill, could be forecasted with a greater reliability and certainty. In addition to the pilot project, we've also been using the LiDAR data to develop slope classifications, hydrography, develop road alignments, develop different canopy height models and digital surface models, the same basic stuff. So just going to pose a question just to get us back on the same page. You know, we talked a lot about the real detail of LiDAR, but why is inventory important? Well, at its core, forest inventory allows us to assess the resources on the landscape and forecast possible outcomes based on management activities. It's an information enabler. It allows us to provide the base data on which land use, modeling, plans, and decisions are made. So, in terms of our management objectives, a good forest inventory facilitates effective and efficient fulfillment of any number of management objectives, ranging from protection and enhancement of soil productivity and biodiversity, to access timber and recreation opportunities, prevention and mitigation of fire and insects or disease, and that's just to name a few. The quality of the inventory needed to address these objectives is proportional to the level of overlapping and competing demands on the landscape. For example, down in the Spray Lake area, there's a lot of complex land use issues. And for those kind of areas, we need a higher quality, spatially explicit inventory that's needed to enable comparisons of management objectives, forecasting landscape attributes, and performing trade-offs with a higher degree of certainty and reliability. So this is our typical adaptive management framework slide. And ideally, our resource management objectives are met within the concept of this adaptive management framework arrangement. We're assessing the current state by modeling baseline key performance indicators and discussing where the opportunities lie and what the desired future outcomes may look like. We're designing and forecasting possible future scenarios based on a suite of indicators intended to allow us to achieve our management objectives. And then we implement those strategies within a preferred management scenario. And then we're monitoring and evaluating those strategies. And then we adjust. So in order for that continual improvement framework to work well, key attributes within a inventory include terrain and land cover, species compositions, and diameter distribution, which are important for deciding when a particular forest management activity should occur. These are important for measuring and inferring value to the non-timber elements on the landscape. Some examples would include determining different wildlife habitats, assessing levels of risk and sustainability of fire and mountain beetle. Many of those we already seen today. Also site productivity, looking at determining changes in tree and stand conditions over time. The site productivity piece would look at involving developing site index models by ecosite or other parameters. So moving to conventional inventories. The conventional inventories within Canada typically have a relatively low level of resolution. I know Murray mentioned it a bit. The polygons in Canadian forests are generally averaging between 10 and 20 hectares and range really from 1 to thousands of hectares in size, depending on where you are. The level of detail is primarily stand-level tree details. We're not at the tree-level detail yet. Much of the detail is subjectively assessed and difficult to verify in the field. Conventional inventories are okay strategically if there is no other choice, but I would say they're limited in their application since they don't carry enough resolution to be used for operational purposes. If these activities that are implemented operationally cannot easily be reflected or reconciled within the strategic plans, then how do we even know if we're operating sustainably at this point in time? We can't really know if the implemented activities are consistent with those strategic or tactical forecasts, or vice versa, until we have more detailed inventories, models, and adaptive feedback mechanisms. Right now, we're bridging the gap by assuming that the implemented operational activities will follow the strategic plans will meet the sustainability objectives. So there's been a number of studies looking at the accuracy of species composition. We're looking at species groups that are assigned on average correctly between 50 and 70% of the time over larger areas in the conventional inventories. Pure species stands, single layered, are the easiest to classify with a success rate of over 80%. Within mixed species, multi-layered or complex stands, that's where the success rate tends to decline. And it declines more quickly where the distributions tend to be patchy and where there's vertical complexity. We're averaging 30 to 50% success rate in those types of stands. So why is that large variation in photo-interpreted species composition occurring? It has to do a lot with scale, which we've mentioned today, setting targets for the desired number of polygons per map sheet. Photo classifiers are trying to estimate species percentages or assign a polygon to a species group in areas that may extend from over 2 to 100 hectares. So we're setting targets for, this delineation process, while experience-based, is still subjective and audited by another trained interpreter. The two interpreters may see things differently, and they may place the boundary in a different spot, make a slightly different call, or lack any objective assessment of what the true location, call, or level of error is. So the key messages that I'm trying to make really is those photo-interpreted species percentages are not necessarily accurate at the scale of individual polygons, and they can be biased on the scale of the whole inventory. Improvements can be made by population sampling, but the within polygon variation that I'll show you here shortly in those larger polygons still limits improvements. The pilot that we're going to be doing over the next year will get a better handle on species compositions. So some of the challenges that we've discussed in the past, and even during the day here, was cost of LiDAR. It was previously seen as a limitation, but LiDAR technology is continuing to develop and the cost is dropping. There are also other types of high-resolution data that may be used to develop forest inventories coming up, 10, 20 years from now. Right now there's 8-band imagery out there. Do we start using some of that? Can we use radar, some other different tools out there? Really, it's important to keep that basic inventory process flexible enough so that as new data comes online, we can use it for operational pilots and trials. The timing of LiDAR data can also impact the LiDAR signature, and it's been mentioned here already today that whether or not you collect the data in the summer during leaf on, you're going to get different LiDAR signatures for that, or during the winter leaf off. The question that we're going to be looking at over the summer or over this next year is whether or not the LiDAR signatures will impact the metrics that we're going to be working with. With respect to the current inventory standards, those were developed for manual photo interpretation processes, and we need to determine and have a conversation around what attributes do we really need. Murray mentioned about age is one. We discussed that last night actually, and that's one that, yeah, it's good for some things, but now we're starting to measure height directly. So Also, what's the best way to get at these different attributes? So this is a comparison of some planning data that we had for the Spray Lakes Sawmills operations within the pilot study area. This is by no means selecting any area with more variation. This is pretty representative. And right now we're looking at heights projected from the growth and yield data sets which were developed as part of the DFMP from the strategic plan. You can see the upper left frame shows the ground polygons at a height of 12 to 17.9 meters. The lower right frame shows the LiDAR grid level, where you got much more variation that exists in the different height classes. You can just see all the different colors there. In the orthophoto, the upper right shows the variation that actually exists within the polygons, but this wasn't represented in the data sets that we used for the strategic planning. And then the lower left one, that just shows the LiDAR-based grid cells where we kept the same ABI line work and we just aggregated it up to the ABI polygon boundaries, the data, and with some statistics. However, you know, based on some of this, the variation, you could probably say, yeah, maybe we need to change some of the line work within the ABI, and you'll see another slide here on the next one to say that. But back on the other page, we can go back here. Really, the key there, this is a height, but so any indicators that you develop based on height in your strategic plans are really going to be impacted by this. Even green up and the adjacency constraints, if they're height-based, are really going to be impacted by this. So, same area again. This time we're looking at volume classes, 1511 utilization. And again, if we look at the lower right image, most of the area is in 1 to 99.9 volume class. So I question whether or not you would even, you know, you've got all this area in the green, you've got all this area up here in the green here, and it just doesn't correspond there at all, right? So whether or not any of the blocks, if you put any blocks in there, if they already had them in for the spatial harvest sequence, would they even be harvested? So given those change in volume expectations, would your timber supply, or would you even still meet your sustainability objectives? We think that this level of detail should be the new standard for operational planning within the province or within the forest sector. The goal is to build an objective, repeatable forest inventory process and product. We're going to be using LiDAR, ground plot data, imagery, photo plots, advanced statistical methods to provide objective estimates of species, site productivity, and diameter distributions. Other metrics that we'll generate will be height, basal area, volume, same ones we did for the previous analysis. Key is to maximize the investment of all ground plot data before establishing new plots. There's a raft of plots out there that you can use from the PSPs, SRD PSPs, government PSPs, even neighboring FMA PSPs, to really get at a regional flavor for that. So to do that, we look at creating a regional plot program. It's probably something that should be thought about to reduce that duplication effort and start pooling the funding for the continued measurement, continued maintenance and remeasurement, especially in light of climate change and other changes that may occur in the landscape. Photo interpreters will still be used. However, we're applying the skills in different capacities by developing photo plot data sets, performing QA, and validation of the imagery data. Validation will also be included as part of the inventory for deriving the more of an objective process and deriving growth and yield information as well. So we can forecast attributes over time in space. So we're currently working with Spray Lake to developing a high-resolution forest inventory for the pilot study area. This will be completed and reviewed by ASRD. We will incorporate 2 distinct products: grid-based inventory, which we've seen a lot of here today, and a polygon-based inventory that clients in the SRD can use for their planning purposes. The high-resolution inventory will include current ABI attributes, but will also include other real-world measures, such as volume, basal area, and diameter. It will include tree lists and stand and stock tables for projection of those future attributes. All this data will allow for more flexible interpretations of landscapes in the valley. With respect to future opportunities, we see this as we want to encourage people to learn to use this improved LiDAR data and capitalize on its benefits. We need to get the processes and tools in place to allow organizations to use the detailed data, and some of those we've seen here today. The real payoff and efficiencies and value of this type of inventory will be realized when it's used for forest and environmental planning processes across organizations and departments. It would increase operational effectiveness and can be used in a number of strategic and operational ways, including timber damage assessments, fire and wildlife habitat, and timber supply, and much more. So the number of benefits that I just came back to. Reduces time in operational planning, provide more meaningful and accurate metrics, produces high-resolution inventory where every square meter of the land base is assessed and attributed, and aligns strategically with operational activities, or aligns strategic and operational activities to ensure meeting those regulatory requirements and management objectives. From a government of Alberta perspective, we think that high-resolution inventory product could fit well within the strategic plans by being a clearly innovative solution to environmental and land use challenges, where an inventory of this resolution would facilitate better decision-making to the land use pressures that we have today, and providing the forest sector and the government at large with more information and efficiencies than they have had in the past, becoming global leaders in sound management and ensuring sustainability and conservation biodiversity. And that brings me to my end of the presentation. Here's the contacts for Ian and myself. You can contact us after the workshop.